Hello. We were looking at methods of recognizing whole families of objects whose shape can vary. And we've looked at the core algorithm, the point distribution point distribution model method. Unfortunately, before we can apply this method, we need to apply some pre-processing to all of the image data to get it into the right sort of shape and form that enables us to be able to use this method. And this is quite a common feature of many computer vision type problems, where you have a clear algorithm that you want to apply, but somehow you need about 90% of the work is in the process of getting the data into the shape that you can use the algorithm, and that's not really any different here. Probably the algorithms that I'm going to talk about in the next few minutes probably run to a couple hundred lines of MATLAB, whereas the core algorithm probably runs on the order of about 10 to 20 lines of MATLAB. Well, the first thing we need to do is actually get the edges and the corners. So here we're going to find the corners of our T-shapes or other shapes. And in the same way that we looked previously with the flat parts, we need to start with our binary image and our gray level image. We need to find the binary image, and then we need to find the edges. And previously, when we looked at the edge segmentation process, we found that we were getting a number of small little segments, okay, where the corners were not found very accurately. So we're going to have to do something about that. And that's the first step we're going to do here. The way we're going to do this is we're going to take advantage of some problem-specific knowledge. And this is why we have this sort of special pre-processing type step, is exploiting that knowledge. What we know is that we have a couple of constraints. One is that we've got long lines on the object. And the second is we know that these long lines meet at corners that are about 90 degrees apart. So rather than using the segmentation algorithm that we had previously that located these little points, and you can see some of the defects of those points, let's take advantage of the fact that we know that these lines actually should intersect. And the way we do that is instead of worrying about the endpoint that was found previously, we start with the segment itself, the two segments, and then we can extend these segments together and intersect them mathematically till we find that point of intersection. And once we've done that, let's use that point of intersection rather than these intermediate points that we found previously. So that's going to remove a lot of these little segments right here. Also, we can take advantage of the fact that all these lines are long, and the way we know which ones to throw away are these little ones. We keep the long ones, we throw away the little ones. So that's the kind of the feeling of the kinds of things that we do in the pre-processing. That gives us these corners. And the second thing we're going to have to do is we're going to have to rotate the T into some kind of a standard position. So what I mean by a standard position is something like this, where originally when we looked at the image, we see the T in any one of a number of positions and orientations in the image. And when we're going to do our point distribution model, what we need to do is we need to get them into the standard position. So to get them into the standard position, we are going to use a heuristic algorithm that takes advantage of what we know about the shape already. So here we know that it's a T-shape, and we know that there's 8 lines on that T-shape. You can see them here. There's 4 parallel horizontal lines and 4 parallel vertical lines. And we're going to take advantage of that. So first step is we sort those 8 lines into 2 sets of mutually nearly parallel lines, so the 4 parallel horizontal lines and the 4 parallel vertical lines. We do this a bit heuristically. We just find the direction of one line, and then we group with it all the other lines that are within pi over 4 radians of the same orientation. So that gives us our 2 sets. Then we need to figure out which of these 2 sets corresponds to the head of the T. And if you look at the shape right here, you'll see the head of the T has 1 long line and then 3 short lines which are about equally spaced apart. And we'll take advantage of that property. Okay, so we sort them, and we see, of the lines, we see which of the lines is the longest, and then we check to see that the other 3 lines, short lines, are about the same length. Okay, and then we say, okay, that set corresponds to the head of the T. And finally, once we have the short lines sorted, and we know which line corresponds to the head of the T and where the center of mass of the object is, we can estimate a rotation and a translation that transforms this shape into the same shape, but this position into that position. And here we see two examples of that. Okay, so that's the kind of pre-processing that we need to do. And once we've got that pre-processing done, all of our shapes will be roughly in this orientation, and now we can use the point distribution model. So what have we learned really here? Well, one is a kind of obvious general fact that you learn from experience is that all of these algorithms need some kind of data in some sort of a standard position or some sort of preparation to be able to use our algorithms. And also that a lot of times the ability to run these algorithms is based on looking at the specific problem that you're trying to work with and develop heuristics or algorithms based on the specific properties of that problem. Thank you.